8. Winds, storms and cyclones. Odisha was hit by a cyclone with wind speed of 200 km per hour on 18 October 1999. The cyclone smashed 45,000 houses, making 7 lakh people homeless. On 29 October, the same year, a second cyclone with wind speed of 260 km per hour hit Odisha again. It was accompanied by water waves about 9 meters high. Thousands of people lost their lives, property worth crores of rupees was destroyed. The cyclone affected agriculture, transport, communication, and electricity supply. Figure image taken by a satellite of a cyclone approaching the coast of Odisha. Courtesy India Meteorological Department, New Delhi. But what are cyclones? How were they formed? Why are they so destructive? In this chapter, we shall seek answers to some of these questions. We begin with some activities involving air. These activities will clarify some basic features concerning a cyclone. Before we begin, remember that the moving air is called the wind. 8.1 Air exerts pressures. Activity 8.1 Do this. Whenever an activity involves heating, be very careful. It is advised that such activities are performed in the presence of an elderly person from your family, or carry out these activities in the presence of your teacher. You need to boil water in the following activity. Take a tin can with a lid. Fill it approximately half with water. Heat the can on a candle flame till the water boils. Let the water boil for a few minutes. Blow out the candle. Immediately put the lid tightly on the can. Be careful in handling the hot can. Put the can carefully in a shallow metallic vessel or a wash basin. Pour fresh water over the can. What happens to the shape of the can? Figure. Can with hot water being cooled? Can you guess why the shape of the can gets distorted? If you cannot get a tin can, take a soft plastic bottle. Fill it with hot water. Empty the bottle and immediately cap it tightly. Place the bottle under running water. Recall now some of your experiences. When you fly a kite, does the wind coming from your back help? If you are in a boat, is it easier to row it if there is wind coming from behind you? Do you find it difficult to ride a bicycle against the direction of the wind? You know that we have to fill air into the bicycle tube to keep it tight. Also, you know that a bicycle tube overfilled with air may burst. What is the air doing inside the tube? Discuss with your friends how the air in the bicycle tube keeps it in shape. All these experiences show that the air exerts pressure. It is due to this pressure that the leaves of trees, banners or flags flutter when the wind is blowing. You can list some more experiences which show that the air has pressure. Let us now try to explain why the can or the bottle gets distorted. As water is poured over the can, some steam in the can condenses into water, reducing the amount of air inside. The pressure of air inside the can decreases than the pressure exerted by the air from outside the can. As a result, the can gets compressed. This activity again confirms that air exerts pressure. 8.2. High-speed winds are accompanied by reduced air pressure. Activity 8.2. Do this. Figure. Blowing into the bottle. Crumple a small piece of paper into a ball of size smaller than the mouth of an empty bottle. Hold the empty bottle on its side and place the paper ball just inside its mouth. Now try to blow on the ball to force it into the bottle. Try the activity with bottles of different size. Challenge your friends if they can force the paper ball in by blowing into the bottle. Paheli and Bojo are thinking about the following question. Why is it difficult to force the paper ball into the bottle? Activity 8.3. Do this. Blow the balloons. Take two balloons of approximately equal size. Put a little water into the figure, blowing between the balloons. Balloons. Blow up both the balloons and tie each one to a string. Hang the balloons 8 to 10 cm apart on a cycle spoke or a stick. Blow in the space between the balloons. What did you expect? What happens? Try different ways of blowing on the balloons to see what happens. Activity 8.4. Do this. Can you blow and lift? Hold a strip of paper 20 cm long and 3 cm wide between your thumb and forefinger as shown in the figure. Now blow over the paper. Paheli thinks that the strip will be lifted up. Bojo thinks that the strip will bend down. Figure. Blowing over a strip of paper. What do you think will happen to the paper? Let us try to understand the observation in activities and what the observation along the lines you thought. Do you get the feeling that the increased wind speed is accompanied by a reduced air pressure? When we blow into the mouth of the bottle, the air near the mouth has higher speed. This decreases the pressure there. The air pressure inside the bottle is higher than near the mouth. The air inside the bottle pushes the ball out. In activity, you saw that when you blew between the balloons, they moved towards each other. How could this happen? This could happen if the pressure of air between the balloons were somehow reduced. The pressure outside the balloons would then push them towards each other. In activity, you saw that when you blew over the paper strip, it went upwards. Again, this could happen if blowing over the paper reduced the air pressure above the strip. We see that the increased wind speed is indeed accompanied by a reduced air pressure. Can you imagine what would happen if high-speed winds blew over the roofs of buildings? If the roofs were weak, they could be lifted and blown away. If you have any such experience, share it with your friends. Let us try to understand how winds are produced, how they bring rain, and how they can be destructive sometimes. You already know that when air moves, it is called wind. Air moves from balloon tied over the neck of the boiling tube immersed in hot water, boiling tube immersed in ice cold water. Figure the shape of the balloon in hot and cold water. The region where the air pressure is high to the region where the pressure is low. The greater the difference in pressure, the faster the air moves. But how are the pressure difference created in nature? Is the difference in temperature involved? The following activities will help you to understand this. 8.3 Air expands on heating. Activity 8.5 Do this. Take a boiling tube, stretch a balloon tightly over the neck of the tube. You can use a tape to make it tight. Pour some hot water in a beaker. Insert the boiling tube with the balloon in the hot water. Observe for 2 to 3 minutes for any change in shape of the balloon. Take the tube out, let it cool down to the room temperature. Take some ice cold water in another beaker and place the tube with the balloon in cold water for 2 to 3 minutes. Observe the change in the shape of the balloon. Think and try to answer. What makes the balloon inflated when the boiling tube is placed in hot water? Why is the same balloon deflated when the tube is kept in cold water? Can we infer from the first observation that air expands on heating? Can you now state what happens to the air in the boiling tube when it cools down? The next activity is very interesting. This will make you understand more about hot air. Activity 8.6 Do this. Take 2 paper bags or empty paper cups of the small same size. Hang the 2 bags in. Caution. Handle the burning candle carefully. Figure hot air rising up. The inverted position on the 2 ends of a metal or wooden stick. Tie a piece of thread in the middle of the stick. Hold the stick by the thread figure as in a balance. Put a burning candle below one of the bags as shown in the figure. Observe what happens. Why is the balance of the bags disturbed? Does this activity indicate that warm air rises up? As the warm air rises up, it pushes the bag above the candle. Does the disturbance of the balance suggest that the warm air is lighter than the cold air? Can you now explain why smoke always rises up? Also, it is important to remember that on heating, the air expands and occupies more space. When the same thing occupies more space, it becomes lighter. The warm air is therefore lighter than the cold air. That is the reason that the smoke goes up. In nature, there are several situations where warm air rises at a place. The air pressure at that place is lowered. The cold air from the surrounding areas rushes in to fill its place. This sets up convection in air, as you learnt in chapter 4. 8.4 Wind currents are generated due to uneven heating on the earth. These situations are A. Uneven heating between the equator and the poles. You might have learnt in geography that regions close to the equator gets maximum heat from the sun. The air in this region gets warm. The warm air rises and the cooler air from the regions in the 0 to 30 degree latitude belt on either side of the equator moves in. These winds blow from the north and the south towards the equator. At the poles, the air is colder than that at latitudes about 60 degrees. The warm air at these latitudes rises up and the cold wind from the polar regions rushes in to take its place. In this way, wind circulation is set up from the poles to the warmer latitudes, as shown in figure. Figure The wind flow pattern because of uneven hitting on the earth. I wonder why the winds shown in the figure are not in the exact north-south direction. The winds would have flown in the north-south direction from north to south or from south to north. A change in direction is, however, caused by the rotation of the earth. B. Uneven hitting of land and water. You have read about the sea bridge and the land bridge in chapter. In summer, near the equator, the land warms up faster and most of the time the temperature of the land is higher than that of water in the ocean. The air over the land gets heated and rises. This causes the winds to flow from the oceans toward the land. These are monsoon winds. Figure. The word monsoon is derived from the Arabic word "mawsam", which means season. In winter, the direction of the wind flows gets reversed. It flows from the land to the ocean. Figure. I want to know what these winds do for us. The winds from the ocean carry water and bring rain. It is a part of the water cycle. The monsoon winds carry water and it's rain. Clouds bring rain and give us happiness. Farmers in our country depend mainly on rains for their harvest. There are many folk songs associated with clouds and rain. Sing and enjoy with your friends. If you know such a song, here is one for you. Roaring clouds across the sky tell us that monsoon's here. Dark and floating clouds then pour raindrops everywhere. Clouds make lightning flash overhead and irrigate fields with rain. Clouds make earth its fragrance spread when wet with drops of rain. Rising from the ocean vast, clouds fill up with rain. Rain to ocean back at last to mingle with ocean again. However, it is not always a happy ending. Rains often create problems. Can you list some of the problems? You can discuss the causes and solutions of the problems with your teacher and parents. In nature itself, there are certain situations that can sometimes create disaster and pose threat to humans, animals and plant life. Let's study two such situations, thunderstorms and cyclones. Figure, uneven hitting of land, especially the Rajasthan desert, generates monsoon winds from southwest direction in summer. The winds carry lots of water from the Indian Ocean. Figure, uneven hitting of land and water in winter generates winds from the northwest cooler land. These colder winds carry little water, hence bring small amount of rain in winter. Courtesy India Meteorological Department, New Delhi. 8.5 Thunderstorm and Cyclones. Thunderstorms develop in hot, humid tropical areas like India very frequently. The rising temperature produces strong upward rising winds. These winds carry water droplets upward where they freeze and fall down again. The swift movement of the falling water droplets along with the rising air create lightning and sound. It is this event that we call a thunderstorm. You will read about lightning in higher classes. If a storm is accompanied by lightning, we must take the following precaution. Do not take shelter under an isolated tree. If you are in a forest, take shelter under a small tree. Do not lie on the ground. Do not take shelter under an umbrella with a metallic end. Do not sit near a window. Open garage, storage sheds, metal sheds are not safe places to take shelter. A car or a bus is a safe place to take shelter. If you are in water, get out and go inside a building. How a thunderstorm becomes a cyclone. You know that water requires heat when it changes from liquid to vapor state. Does the water give back heat when vapor condenses into liquid? Can you recall any experience to support this? Structure of a cyclone. The centers of a cyclone is a cam area. It is called the eye of the storm. A large cyclone is a violently rotating mass of air in the atmosphere, 10 to 15 km high. The diameter of the eye varies from 10 to 30 km. Figure. It is a region free of clouds and has light winds. Around this calm and clear eye figure, there is a cloud region of about 150 km in size. In this region, there are high-speed winds, 150 to 250 km per hour, and thick clouds with heavy rain. Away from this region, the wind speed gradually decreases. The formation of a cyclone is a very complex process. A model is shown in figure. Before cloud formation, water takes up heat from the atmosphere to change into vapor. When water vapor changes back to liquid form as raindrops, this heat is released to the atmosphere. The heat released to the atmosphere warms the air around. The air tends to rise and causes a drop in pressure. More air rushes to the center of the storm. This cycle is repeated. The chain of events ends with the formation of a very low pressure system with very high speed winds revolving around it. It is this weather condition that we call a cyclone. Factors like wind speed, wind direction, temperature, and humidity contribute to the development of cyclones. Figure formation of a cyclone. Gales gradually increasing, hurricane winds, gales gradually decreasing, direction in which cyclone moving, the stream flow, I, sinking air, outflow, rising air, 15 km. Figure the image of the eye of a cyclone. Figure rising water caused by a cyclone. Eight point six destruction caused by cyclones. Cyclones can be very destructive. Strong winds push water towards the shore even if the storm is hundreds of kilometers away. These are the first indication of an approaching cyclone. The water waves produced by the wind are so powerful that a person cannot overcome them. The low pressure in the eye lifts the water surface in the center. The rising water may be as high as 3 to 12 meters. Figure. It appears like a water wall moving towards the shore. As a result, the seawater enters the low-lying coastal areas, causing severe loss of life and property. It also reduces the fertility of the soil. Continuous heavy rainfall may further worsen the flood situation. High-speed winds accompanying a cyclone can damage houses, telephones and other communication systems, trees, etc., causing tremendous loss of life and property. A cyclone is known by different names in different parts of the world. It is called a hurricane, in the American continent. In Philippines and Japan, it is called a typhoon. Figure. Figure regions near the equator where cyclones form. Cyclones are worldwide phenomena. The diameter of a tornado can be as small as a meter and as large as a kilometer or even wider. The funnel of a tornado sucks dust, debris, and everything near it at the base due to low pressure and throw them out near the top. Here are a few accounts of the survivors of tornadoes from Discovery Channel's Young Discovery series. Figure. Protecting from a tornado. I saw the cloud coming and tried to take shelter inside. But as soon as I reached for the doorknob, the house took up into the sky. I was not hurt at all. After the storm, we had to clean the debris from the wheat fields. We picked up splintered boards and tree branches as well as dead chickens with their feathers blown off, and rabbits looked like they had been skinned. A tornado shelter is a room situated deep inside or underground having no windows, or otherwise it is better to shut windows and take shelter under a table, workbench where debris cannot reach. One has to bow down on knees protecting heads and neck using arms. Figure. North Pacific Ocean, typhoon, cyclone, hurricane. South Pacific Ocean, North Atlantic Ocean, hurricane, cyclone. Indian Ocean, North Atlantic Ocean. Tornadoes. In our country, they are not very frequent. A tornado is a dark funnel-shaped cloud that reaches from the sky to the ground. Figure. Most of the tornadoes are weak. A violent tornado can travel at speed of about 300 km per hour. Tornadoes may form within cyclones. The whole coastline of India is vulnerable to cyclones, particularly the east coast. The west coast of India is less vulnerable to cyclonic storms both in terms of intensity and frequency of the cyclones. 8.7 Effective Safety Measures. A cyclone forecast and warning service. Rapid communication of warning to the figure. Image of a tornado. National Severe Storm Laboratory, NSSL, courtesy, India Meteorological Department, New Delhi. We have learned that all storms are low pressure systems. Wind speed plays an important role in the formation of storms. It is therefore important to measure the wind speed. The instrument that measures the wind speed is called an anemometer. Figure. An anemometer for measuring the speed of wind. Courtesy, India Meteorological Department, New Delhi. Government agencies, the ports, fishermen, ships, and to the general public. Construction of cyclone shelters in the cyclone-prone areas and administrative arrangements for moving people fast to safer places. Action on the part of the people. We should not ignore the warnings issued by the meteorological department through TV, radio, or newspapers. We should make necessary arrangements to ship the essential household goods, domestic animals, and vehicles, etc. to safer places. Avoid driving on roads through standing water, as flows may have damaged the roads and Keep ready the phone numbers of all emergency services like police, fire brigade, and medical centers. Some other precautions if you are staying in a cyclone hit area: do not drink water that could be contaminated. Always store drinking water for emergencies. Do not touch wet stitches and fallen power lines. Do not go out just for the sake of fun. Do not pressurize the rescue force by making undue demands. Cooperate and help your neighbors and friends. 8.8 Advanced technology has helped. These days we are better protected. In the early part of the last century, coastal residents may have had less than a day to prepare or evacuate their homes from an oncoming cyclone. The world today is very difficult thanks to satellite and radars. A cyclone alert or cyclone watch is issued 48 hours in advance of any expected storm, and a cyclone warning is issued 24 hours in advance. The message is broadcast every hour or half hour when a cyclone is nearer the coast. Several national and international organizations cooperate to monitor the cyclone-related disaster. Keywords: anemometer, cyclone, hurricane, lightning, low pressure, monsoon winds, pressure, thunderstorms, tornado, typhoon, wind flow pattern. What you have learned: air around us exerts pressure. Air expands on heating and contracts on cooling. Warm air rises up, whereas comparatively cooler air tends to sink towards the Earth's surface. As warm air rises, air pressure at the place is reduced and the cooler air move to the place. The moving air is called wind. Uneven heating on the earth is the main cause of wind movements. Winds carrying water vapor bring rain. High-speed winds and air pressure difference can cause cyclones. It has become easier to monitor cyclones with the help of advanced technology like satellites and radars. Self-help is the best help. Therefore, it is better to plan in advance and be ready with defense against any approaching cyclone. The following flowchart will help you to understand the phenomena that lead to the formation of clouds and falling of rain and creation of storms and cyclones. Difference of temperature between two regions. Sets convection in air. Warm air rises, creating a low pressure area. Cool air converges to the low pressure area. Warm air rises, cools, and the water vapor condenses to form clouds. The bigger water drops in the cloud fall to the ground as rain, hail, or snow. Falling water droplets and rising air move vigorously to produce thunderstorm. Under certain weather conditions, storms may develop into cyclone. Exercises: do this and comment this. Extended learning activities and project. Figure: finding centers of the strip. Figure: a model of an anemometer. Figure: caution: when you perform this activity, make sure that nobody is standing in front of the tube. You can read more on the related topics on the following website: http www.imd.gov.in. Did you know a bolt of lightning travels at a speed of more than 4 lakh km per hour? It can heat the air around it to a temperature which is more than 4 times the temperature of the surface of the sun. That is what makes lightning so dangerous.